We spent a lot of time in class the last week really working on converting improper fractions to mixed numbers and mixed numbers to improper fractions. It's something that's really important that the kids understand because it ties into a lot of the different things we do with fractions. So, and I know they'll encounter it later in school as well. So it's just something we need to kind of nail down. So thought I would go over both of those for parents and for students in hopes that maybe we can get this figured out soon. So if we're converting from mixed numbers to improper fractions, a mixed number, remember, is going to have a whole number, and then it's going to have a fraction. That's why it's mixed. And so if I were to draw a picture of what this looked like, it would look like this. And two wholes would be colored in, and then 1/3 of the other one. So you would have 2/3. And so the process of converting this mixed number to an improper fraction is just to take that whole number of 2 times the 3, which gives you 6, plus the 1, and it would be 7/3. So it's improper because it's not right. Normally we think of a fraction as having the numerator, the number on top, as being smaller than the denominator. And so it's 7/3. And if you look at the drawing we just did, you can see that if I count these thirds, there are 1, 2, 3, 4, 5, 6, 7 1/3 colored in. So the picture really matches both of those, 2 1/3 and 7/3. So we'll do another one together again. Let's say we had 4 and 5/8. We would take 4 times 8, which is 32, plus the 5, which is 37, and we are talking about eighths. I'm not going to draw that one. It would take a long time. But if you counted the eighths up, you would have 37 1/8. So that's how we go from a mixed number to an improper fraction. Now, if we want to go the other way, from an improper fraction to a mixed number, and this figures into a lot of, like I said, a lot of what we do. It's going to figure into subtraction of mixed numbers, which we're going to do next week. So let's say we had 15/4. And so obviously it's improper because the larger of the two numbers is on top, but we're talking about fourths. And so to convert it, I told the kids to think of it a few different ways. One way is just how many groups of 4 could you take out of 15? Another way is, and what you're really doing is you're dividing this numerator by the denominator. It's the same thing. How many groups of 4 can you take out of 15? You could also, I told them you could make 15 counters. The danger of that is sometimes you get off on your counting, or when you're circling groups you make a little mistake and it can throw your answer off. But it is an all right strategy to use, especially for smaller numbers. When we start getting into bigger numerators, though, then it becomes pretty impractical. If I were to use counters, though, and hopefully I have 15, I would just see how many groups of 4 I can take out of 15. Basically the same question I have up above. I'm just going to show it graphically now. And so you can see 1, 2, 3. I can take 3 whole groups of 4 out of 15. And what's left over? 1, 2, 3. There are 3/4 left over. Same type of thing. If you were going to draw this, there's 3 whole right there, and there's 3/4. Or if we count the fourths, there would be 4, 8, 12, 13, 14, 15 1/4 shaded in. So I like them to think of it this way because we are starting to work with division now. We've started, today we spent a lot of time on 2-digit division, or dividing a 2-digit number by a single-digit divisor, and just trying to get through that cycle, understand that cycle. And we talked about repeating the cycle. A number of kids still struggle with that. But if they can get the idea that this is 15 divided by 4, or how many groups of 4 can you take out of 15, I think it's going to help them a lot. So I encourage them to practice this. If you, as parents, just want to write some improper fractions and have them convert them, the more practice they get, the better.